There we go. Sorry, we didn't. Oh wow! I didn't see that anybody was actually online. So YouTube is lying to me, and you've got there are actually 2 or 3 people online. Sorry about that. Let me know if that fixed the issue in the chat. Otherwise, we were just basically going over a review of what we've already covered. Again, the motivation is that you want to provide a way to reuse code, a way to organize code. Right? Let me go ahead and check manually, actually. Okay, yeah, we're good now. Sorry about that. All right, so to go back to our organization here. So as we already saw with abstract, that you can make things abstract if it's not well defined, right? An account, a generic account, what's its value, right? I have no idea. I don't have any idea how to even answer that question. So I'm not even going to bother trying to answer that question, and I'm going to make that method into an abstract method, right? Just like a generic animal. What is it? How does an animal speak? Well, a dog barks and a cat meows, but what does a generic animal do, right? Yeah, well, not all of the animals are able to make sounds, right? So I'm not even going to bother, answering that question. I'm going to make that into an abstract class. Then an abstract class can have abstract methods. Methods that do not have a body and force the subclasses to actually specify the behavior. Dog, you will bark, right? Cat, you will meow. With abstract classes, you can also prevent somebody from creating instances of them. Now, sometimes you want to prevent inheritance, right? So for example, let me go ahead and undo this, right? Sometimes you want to prevent subclassing. Here's an example, right? Should anyone be allowed to change the behavior or expectations of, say, an integer class? We all have a good idea of what an integer is. It's a whole number, positive, negative, and 0, right? And we also have an idea of how an integer behaves. 10 plus 20 is 30. Should I go messing with that? Should I go ahead and mess with it so that, well, 10 plus 20 is, now it's 31? No. You don't want to allow people to make changes with respect to variables sometimes, do you? Right? So for example, another example here with variables, some variables should be constants. For example, math.pi. Should you allow anybody, I don't want to allow anybody to change pi to 4 or just 3 or 3.1 or something like that, right? So how does it work? We make that variable final, right? To make it constant, you use the final keyword. You can do that with a class. You can use final on a class to prevent subclassing. Now again, why would you want to do that? Well, because there are well-defined expectations of what a string is. There are well-defined expectations of what an integer is. Let's go ahead and jump into that class here, integer. Got to spell it correctly. Jump into that class and see how it's defined. There's that final keyword. You would not be able to create another integer, a subclassed integer, my awesome integer, that wherein addition means subtraction and subtraction means multiplication, right? We don't want to go messing with that show, right?
Not allowed to modify integers so you can divide by 0.
Exactly. You don't. Well, that would be an excellent potential use case. That I would define division by 0 to be, I don't know, infinity, right? Something like that. In a programming language like C++, it's the complete Wild West. You can do whatever you want. You can do that, right? You can redefine plus on integers to mean minus, right? Why would you want to do that? You wouldn't want to, but in a programming language like Java, you are completely prevented from doing that at all, right? So, no, not a good idea. Same thing with strings. They are final as well. Right? If I can jump into that class, final. All the built-in types are final because they are built into the language and there is a well-established expectation of how they behave. You don't want people going messing with that. Right? And so to prevent that, you can have final on your class. You can also use it on a method. You can use final on an individual method to prevent overwriting that method. Right? So for example, one of them that we override, the only one that we override here is get value. I can make that in final, and now it's not going to compile for other reasons, but now these subclasses will not be able to provide their own implementation of that. Again, if you have an expectation that there is a certain behavior for this certain method, I don't want you going messing with that. I'll make it final, right? The term for that is a virtual function, right? By default, all methods in Java are virtual, which means that they can be overridden. Using final makes them non-virtual. That's just the opposite in C++. Everything by default is non-virtual. And then what you do is you use the keyword virtual in front of the method to make it so that you can override that function, right? So there are ways of preventing this stuff and preventing bad designs, okay? Yeah, go ahead.
Would an example of a time where you need to modify the outcomes of, when you need to modify the answers for math, is
Right.
something like 0 to the power of 0 or something?
That's not, I don't even think that's well defined. 0 to the power of 0. I think you'd get 5 different answers from 5 different mathematicians.
Yeah.
So you don't want to go messing with that. Whatever we have well-established standards in computing, IEEE standards of what happens when you do certain things, and those standards control. Otherwise, it's not IEEE 754 compliant, right? And so there are governing bodies that dictate or that establish these standards, and you don't want to go changing them. Right?
That's an instance I thought of where.
Yeah, you wouldn't probably want to do that. You'd probably want to bring in a custom library or something to do things differently. But another way of doing this is a pure abstract class. So this pure abstract class is one in which there are no functions defined. And in Java, we call those interfaces. Right? This allows you to now this allows you a couple of things here. But let me go ahead and show you a picture of it first. Here's the collections hierarchy, right? An abridged version of the collections hierarchy. So we've got a tree set. We've got a couple of sets down here. We've got a couple of lists over here. We might be familiar with a hash set and array list because we've used those before, but there are other types, right? Down here in this third version, or in this lowest level here, those are all concrete classes, right? Those are classes that you would actually use. Then we have this middle part here. This is these are all abstract classes, just like our account is abstract. Then above that, we have a pure abstraction. These are all interfaces. There are 0 methods and 0 functions or variables defined in any of these interfaces, right? The reason is we want we want control over this is concrete, this is absolutely abstract, and then we've got things in between, right? And basically, some of these define state, some of them define properties. For example, random access. From Computer Science 1, do we remember what random access is? So if I've got an array, right, there's a memory address, and I want to go to the 5th element. How do I go to the 5th element? So 5 times however many bytes are over, right? 4 bytes or something, right? So 20 bytes over, 4, 8, 16, 20. There's my 5th element, right? That's random access. Just being able to jump to a memory location for free immediately. Random access, it's saying that the array list has random access. Why? There's an array there, right? But over here, linked list does not have random access because it stores things completely differently. We'll take a look at that later on. So random access doesn't even, this interface doesn't even define any methods at all. It just defines a property of that thing. Sometimes we call these mix-ins. So if you go to, my favorite ice cream store is Cold Stone, right? You go to Cold Stone and they slap the ice cream on the top, and what do they do then? They ask you, what mix-ins you want, right? So I want M&Ms, I want peanut butter cups, whatever, right? And then they mix it in, right? That's what the, say what?
That was an awful pun.
No, it's not. That's exactly what it's called, right? You're mixing things into your classes, right? And this happens in programming languages like, say, Python or JavaScript, which have duck typing. So if I have something in my hand, how do I know it's a duck?
Because it's called a duck.
It's, okay, how do I know it's a duck, though? What's the old adage? If it looks like a duck, it talks like a duck, it's a duck, right? So if I have this object and I put in this quack method, and I put in this waddle method, right? Then it's a duck, right? That's a mix-in. I'm mixing those two things into that thing. Now that doesn't happen with Java because Java, it has static typing. So Java instead has interfaces that you can mix in, right? And deck queue, we'll talk about those later. But anyway, this allows you to extend implement multiple interfaces, right? So when you have an implements, you can implement 1, 2, 3, 4, right? For example, linked list here. It has 1, 2, 3, 4 interfaces that it implements. But you can only ever, in Java, extend one class. We call this a single inheritance hierarchy. Right? But you can implement multiple interfaces. Right? Here's another example. So in a particular company, we have two types of employees. We have hourly employees and salaried employees. They're paid differently, just like in your Lab 5 this week that's due tonight, right? But we also have interns, and at this particular company, we're not paying our interns, right? So if we put them into that inheritance hierarchy under employee, we would be forced to implement that function and just simply return 0 all the time, right? That's the hackish way of doing it. Instead, I'm taking that intern and putting it outside that hierarchy so that I don't actually pay them, right? And then I specify that employees are payable using an interface, but also somebody who's not a person, a supplier, which is a company, I also have to pay them. Otherwise, they don't supply me with the raw materials that I need to do my business. Right? Right? Yeah. So, but an employee is implementing two things. An employee is a person, and we have to pay them. And by extension here, an hourly employee, we pay them, and a salaried employee, we pay them. But an intern is just a person, they're not payable. Right? And a supplier is just payable, they're not a person, it's a company. And so this is a use case where you would want to use interfaces instead, because you are giving properties or behavior or something, and it's keeping you out of the hierarchy. Imagine if we didn't have interfaces, and we locked something into this hierarchy that didn't really belong. What's another smart data structure that you don't see in this picture? We've looked at sets, we've looked at lists. What's the other thing that we've looked at? Maps. Do you see maps here? No, why? Right? Is a map sometimes a list? How is it like a list? It holds stuff. So it's a collection, yeah, but it doesn't hold stuff normally, right? It holds stuff in a key value pair mapping, right? Is a list like a map? It holds stuff, but there's no key, there's just values, right? So it doesn't really make sense to lock a map into this hierarchy here. And so it's not, it's completely a separate hierarchy. If they had put it in here, then basically sometimes if you had a map, sometimes you'd be forced to treat it like a list. If you had a list, sometimes you'd be forced to treat it like a map, even though it doesn't make any sense. Right? Yeah.
So a map isn't, so it's not a class and.
A map is a class, definitely. You'd have to look up the map Java.
It's not in the.
It's an interface. And then that interface, implementing interface, let's just look at hash map. There we go.
Is it an interface or a class?
A hash map is a class. Map was an interface. There we go. It's there's an abstract map, and then there it implements the map interface, and so it looks kind of like this this inheritance hierarchy, but it's a completely separate hierarchy.
So a map would be a type of interface.
No, well, yeah, a map is an interface, yes. Just like a collection is an interface, a set is an interface, and a list is an interface. Okay. All right. So it allows you to do multiple things. And here's the syntax for doing it. I'm just going to go ahead and collapse all this stuff. And all accounts are ownable. So what I'll do is I'll create an interface here, new interface, ownable. There we go. Right. And we'll define anything that is ownable has this method that you can get the owner of, right? So public person get owner. There we go. And now what I can do is over here in the account class, I can say that it implements ownable. There we go. And now my picture down here has changed. It implements that interface, and we're good to go already because we already had that get owner function. What if I didn't have that get owner function? Now it's going to start complaining. Why? Savings extends account, which implements the ownable interface. But you do not have an owner, get owner method here, right? So putting that in the superclass means that that it takes care of the issue. Undo this. There we go. Right. So again, it looks something like this. It depends on how you want to design your classes. Right. Strictly speaking, for your assignments or for your projects, you may not have a need for an interface, but it is necessary to understand how they work. Okay. If you find a way to integrate an interface, great, go ahead and do it, and if you want to. Right? So now we get into some pitfalls of inheritance. Right? The first pitfall is that some languages support what is called multiple inheritance. Right? You can inherit from more than one class. Right? Java is not one of them. Right? Instead, use interfaces. C++ does allow this. What is a potential problem of this? Let me go ahead and show you this picture again, where I've got an animal. Right? All animals speak somehow. Right? A dog speaks by barking, and a cat speaks by meowing. Right? What if I were to inherit from both the dog and the cat? This is the third section I've done this in. So, is there at least one person that remembers the cartoon?
Cat dog?
Yeah, cat dog. Right. Two people, 3 people remember cat dog?
I never watched it.
Oh, okay. You remember? You at least remember it, right? Cat dog. So what? There it is, right? It's an animal with 2 heads, right? One on each side, right? In other words, it looks like a freak of nature. And C++ allows you to do something like this, right? But when you do, tell me, what does cat dog say? Does it meow or does it bark? So in a programming language like C++, you are forced to deal with this ambiguity, right? This leads to what's called the diamond problem, right? This is the diamond problem. There is an ambiguity in what is inherited. Right. So let's see. Why is it called the diamond problem? It looks like a diamond, exactly. Right. We're not that creative here, you know. Right. Don't.
Would that be solved by creating an override for C?
That's the issue. The C++ solves this by requiring you to explicitly state what you are inheriting, right? Inheriting, right? So in other words, you have some extra steps to begin with, right, to resolve that ambiguity. So why have that ambiguity at all? Most programming, like Java, C#, I believe, most of them don't allow you to do something like that. Instead, it's a single inheritance strategy. You can only extend from one class. All right, and so that's the solution. Right? Don't even bother having that feature. Again, C++ is the only one that I know of that allows this. Why? Everything in C++ is the wild, wild west. Right? You can do anything you want. Another anti-pattern. A pattern is a good habit to get into and a good thing to follow. An anti-pattern is just the opposite, an antonym of that. It is a bad habit to fall in. There's an anti-pattern called the yo-yo problem, right? Or the yo-yo anti-pattern. So deep inheritance hierarchies can be very confusing, especially if you don't spell hierarchies correctly. There we go. All right. So think about, I'm really going to design the hell out of this and put in like a dozen different subclasses. Okay, now I need to use this one. Which one do I want to use? Okay, there, that's the one I want to use. Wait, where did it inherit that first thing? Okay, I jump up there and okay, it inherited, it established it there. Where was it actually written? Okay, there it is, and it overrides there, and then it inherits there, right? If it's deep, what am I always doing? Looking up and down to see what, to make heads and tails of it. I'm following it up like a yo-yo going up and down, up and down, up and down. It can be very confusing. Generally, keep your hierarchies shallow. Don't go 12 layers deep or anything like that.
You mean I shouldn't just structure the entire?
No, you don't want. You don't. Even something like the animal kingdom, King Philip deserves fudge, whatever it is. That's way too deep. This is not that deep. 1, 2, 3, 4. Right. That's all it is. Now, you could argue that it's 5, 6 with the interfaces, but that doesn't generally count. Right. This is only a 4-layer deep inheritance hierarchy. That's fine. Going any more, probably not what you want to do. You would probably be doing the yo-yo anti-pattern at that point. Right? And another anti-pattern is the rectangle problem. Right? So for that, let me go over here to demonstrate some code in another section. Here we go. I'm going to go ahead and close all this stuff for now. Right? And let's look at the shape, the square, and the rectangle. Right? So here's my inheritance hierarchy. It looks initially okay. Is a square a rectangle?
Yes.
Yes. Is a rectangle a shape? Yes. Is a square a shape by transitivity? Yes. It looks okay. But now let me go over here to the square class. I'm creating a square that is 10 by 10. All right? Good so far. But then I set its height to 5. Do I have a square anymore? No, it's 5 by 10. That's a rectangle. But I'll print out the area here. Is it an instance of a square? Yes. Once you've created something, you cannot change its type. Once you create an int x, you can't force it to become a double, right? So let me go ahead and play this, and we'll look at the output here. Even though it's 5 by 10, 50 square feet or whatever it is, it's still a square, even though semantically it's not, right?
Well, your first mistake was making the height changeable.
There you go. This violates what's called the Liskov substitution principle of the solid principles, which we'll talk about at the end, right? This is by allowing mutable objects, you are allowing something that is sometimes, let's go over here to the plant UML, sometimes a square. By allowing it to mutate, you're allowing it to become a rectangle, right? Even though it's not a square anymore. Sometimes this is known as the circle ellipse problem for the same reason. A circle is an ellipse, but ellipse is not a circle, right? Thinking about rectangles and squares is way easier, right? So I don't bother with that, right? But they're all shapes. Don't lock yourself into a hierarchy here, or prefer immutable objects so that you don't violate the Liskov substitution principle. Right? That everything should be substitutable as a supertype. Right? So that's the diamond problem, right? And
What is the point of having a square class in the first place?
good question. I don't know. Well, no. So I do a VR course in Lincoln, and we use Unity, and they have these prefab shapes so that you can put like a cube or a sphere or something into the scene so that you can interact. And then more complex shapes are built by unioning these things together, right? And we like simple shapes because simple geometry is way easier for collision detection, right? We like concave shapes because of that. That's why typically if you've got like a V-shaped enemy, your hitbox is not V-shaped. Your hitbox is going to be like just a sphere that approximates it so that you can This is why sometimes you see glitches in games where you shoot at an enemy and you visually you don't hit them, but you're hitting this invisible hitbox that is surrounding them, right? And so that's because it's way easier to detect collision on a circle or a sphere than it is on some weird polygonal shape, right?
Collision is hard, okay?
Yes, exactly. All right, so any questions on inheritance? Otherwise, we'll explore something even more powerful than inheritance, polymorphism. So you Latin speakers out there, tell me, what is polymorph? Let's break that up.
Many morphs body or something?
Many bodies, or I'll go ahead and call it forms, right? Many forms. Polymorphic behavior, many forms. It's from biology. So if you take a species of animal, they have what are called phenotypes. You know, dogs. Dogs are all the same species, but would you ever mistake a Saint Bernard for a Shih Tzu or something, right?
Yes.
No. Oh, yes, you would?
I don't know the difference.
Well, they have different phenotypes. One is very large, one is very small. One has wiry hair, one has, you know, shedding hair, whatever, right? Those are phenotypes and polymorphs, right? Different forms of the same animal. In code, it simply means that a variable, method, or class can be generically programmed to apply, so that it can apply to or be used with multiple different types. Now you've seen this, we just didn't call it polymorphism. In C, how do you sort? How did you sort? Q sort. In other words, did you have a Q sort for integers, and a Q sort for doubles, and a Q sort for accounts, a Q sort, Q sort, Q sort, Q sort? No, you had one Q sort. It was kind of polymorphic in that you could apply it to an array of any type, as long as you gave it a comparator of that type, right? That's kind of polymorphic code. Now, in C, we call that generic coding, right? It is a generic function, right? In Java, polymorphism itself appears in many forms, right? So we're going to talk about some of those forms. The first one is going to be the obvious one, which is subtype polymorphism. The example is treating a subtype as a superclass, right? So that you don't have, that you can treat it more generally, so that you can treat it more generally. We've already done this. Remember the demonstration over here where I created 2 savings accounts and 2 annuity accounts? Right? Initially, what I did is I created two lists, one for savings accounts, one for annuity. But after I did the inheritance, did I have to do that? No, I just have one list to rule them all. Oh, right? So that's a polymorphic subtype. I'm taking a savings account and I'm treating it as an account, and I'm taking an annuity account and I'm treating it as an account, so I don't have to have multiple different lists. That's what subtype polymorphism is. It's basically covariance, which is always safe, right? Okay. That's subtype polymorphism. Other types of polymorphism would include function overloading. Right? So recall from C, how do you compute the absolute value? What functions were there?
ABS.
ABS?
Or I guess
Which one was that for?
Those
For integers. If you had a double,
Flabs.
babs, all right? Flabs. Floating point, long floating point. I don't know if there is a flabs or not. There's also a labs though. Y for longs. There's a labs. Y for long longs, exactly, etc. Right? In other words, without function overloading, you can only ever have one function with the same name. Right. Now, let's take a look at Java. Observe the Java. What about math dot, say, absolute value? Right. Let's take a look at that. I'll do it down here. I have an integer, x is equal to -42, and I want to take the absolute value of that. Math dot abs of x. Okay? Let's take a look at what that function looks like. It takes a what? An integer. All right. Now I don't care about the result, so I'll leave it at that. Double y is equal to negative 3.5. I want to take the absolute value of that. Whoa. I have two functions in the same class with the same name. Are they the same function? Nope. That takes a double. This is what's known as function overloading. The same name in the same context, but it takes different types of variables. So now you're the compiler, right? I'm not going to call you dumb, but compilers are dumb, right? I'll take that on myself. I'm a dumb compiler, all right? So how do I figure this out? All right, well, there are two absolute value functions, one that takes an integer and one that takes a double. Which one did you mean to call?
The one that takes an integer and the one that takes a double.
Yeah, how do I know that?
Because you put in an integer.
Yeah, I see x. What is x? X is an integer. So therefore, you must have meant to call that one right there. I'll take care of that for you. What about this one? You gave me y. Y is a double. Therefore, you must have meant to call this function over here. And by the way, that's not the only ones. There's also one for float. There's also one for, these are abs exact. And there's one for long, et cetera, et cetera. There are at least 4 of them in here. Right? One for each type of primitive numerical value. Right? That's called function overloading. Right? There are multiple functions with the same name, but different type or arity. And when we say arity, we mean number of parameters. Right? So if you had a function called foo and another function called foo, one of them took an integer, one integer, and the other function took 2 integers. You'd be able to disambiguate that too, right? Because did you call foo with 2 integers or 1 integer? Okay, 1 integer, you meant this one up here. 2 integers, you meant this one down here. That's what we mean by arity, right? Number of parameters. So as long as the type of parameter is different and or the number of parameters is different, the compiler, a dumb compiler, can still figure that out, right? At compile time, the compiler, again, is smart enough to figure out which one you meant to call. This is known as static dispatch. Right? Why do we call it static dispatch? Static refers to at compile time, and dispatch refers to dispatch. Right? If you're a dispatcher, maybe it's an old-timey term now because we don't have taxis anymore, but taxi dispatch. Right? Somebody calls up, I need a taxi. Okay, I'll send a taxi to 1234 A Street. Right? All right, somebody needs, I'm dispatching that taxi to go out and do that. Or, cops still call it dispatch, right? So dispatch. Right? You are saying, okay, you passed in an integer here. I will dispatch it to this one right there. Right? Me just clicking it was a dispatch, right? You are delegating it to that particular function over there. So again, as long as the number of parameters is different or the type of parameters is different, the compiler is able to determine which one you meant by looking at how you called the function. Not all programming languages, even object-oriented programming languages, support this. For example, Python, there is no function overloading. Instead, it's a little bit different. What happens is you can make parameters optional. So if you've got a function in Python where you've got, say, 4 parameters, you can define default methods. You can call that function on just the first 2. You can call that function on none of it. And then basically what happens is in that function, it becomes your responsibility to determine, oh, they only gave me 2 parameters. I'll do this thing over here. Oh, they gave me 3 parameters. I'll do that thing over there, right? And now it's, I do not like programming like that at all because that forces you to put everything into that one function on all the different possibilities into that one function. It's gross, right? No. Go ahead and, if you don't have function overloading, you might as well just suck it up and do it as C does, right? All right, an abs, fabs, labs, lalabs, right? Another function, another function, another function, different name, different name, different name, right? All right, that's function overloading. We also have what's called operator overloading. Question online? Okay, nope. Just saying it worked. All right, So in Java, let's say string plus, or here, I'll go into code here. String plus string means what? Concatenate. Concatenation. There we go. All right. What if I did string plus an, well, here, let me go with something more obvious. An integer plus an integer. What does that mean? Well, oh, sorry, I meant plus. All right, there we go. Means what? Addition. All right. What if I do this? String plus an integer. What does this mean? Right, means convert the integer to a string and concatenate. There we go. Right, so there's also another, hidden implicit process there, right? Okay, let's go ahead and, you might, does anybody know Python? Okay, Python. What if I got string plus string? Means concatenation, right? What if I did integer plus an integer? Means addition, right? What if I did string plus an integer in Python? Error, right? It doesn't allow you to do this. You are required to explicitly cast the int as a string. And usually what you do with that is you take the integer and you put it into this str function so that it automatically converts it to a string. We don't have that in Java. We don't have that problem in Java. Why? Because we have operator overloading. The operator itself is polymorphic. Depending on the values that you use with it, it has a different meaning. Right? Here it means concatenation, addition. Here it means do this other thing and then do the concatenation. Right? In Python, it's completely different. What about C? Int plus int is addition. What if I did a string, or well, how is a string in C? Char star plus char star, right? Is memory addition, which is meaningless. Take that memory address, and do what? Add them together and get some other memory address that probably doesn't even belong to you, right?
You need a string function for that.
Exactly, str cat or something like that, right? So I can give you at least two other languages in which the meanings are completely different from these. For example, Python, PHP is exactly the opposite of Python. What it does is, okay, I'll take that string and try to make it into an integer instead, right? And if it works, it works. If it doesn't, I'll give you 0, right?
Wait, it's the opposite of Python.
Sorry, it's the opposite of Java. It means convert the string to an integer so that you can add it, right? It doesn't mean concatenation. Right? JavaScript is another one that does things completely differently. The idea here is that in certain languages, you can override, or they are already overridden, operators. In some languages, some operators, such as plus, have more than one meaning depending on the context or types they are used on. Right?
Well, at least int plus int is consistent.
Yeah. Now let's talk about the bad, not the bad language, but the Wild West language. Wild West. I'm gonna start calling it what it is. It's anarchy language, right? You can overload any operator. Right? So let's just think about that for a second. Right? Some things might make sense. For example, if I did list plus list. Right? And C++ does have lists, but that's the STL library. We won't get into that. Just let's think conceptually. What does a list plus a list mean?
Well, assuming they're both of the same type, would be
Okay, both of the same type, so 5, 6, 7. What would the result there be in your mind?
3, 5, 6, 7.
Say it again.
1, 2, 3, 5, 6, 7.
1, 2, 3, 5, 6, 7. Okay, so your interpretation there is append. Okay. Is there another interpretation?
Adding the contents of the list together.
Okay, so that would be what? 6, 8, 10?
Yeah.
That's vector addition. If you were mathematically oriented, or you just come from I don't know, where is where are vectors? Calculus, yeah. If you're coming from calculus. 3? Okay. Vector calculus, right? Then you'd say, oh, well, that's clearly vector addition, right? Both of those are completely reasonable interpretations. So which one is it? Right? There, ultimately what you would have to do is you'd have to read the documentation. And if you're forcing yourself to read the documentation, why not just make a function that says append? Why not just make a function that says vector addition, right? You are adding confusion by saving on typing. That's terrible, right? That's terrible design, right? There are other reasonable interpretations, right? It is better to just make a well-defined, well-named function to take care of it. Because you get into things like, for example, duration plus duration. That makes sense. 5 hours plus 30 minutes is 5.5 hours. But what is time plus time? What is 9:30 a.m. plus 1:30 p.m.? It's ill-defined. Ill-defined, right? So why? What about set plus set? I don't know if you have a formal discrete math course here at UNO, but you could be union, intersection, right? It could be symmetric difference, right? I wouldn't interpret it as that, but you could, right? In C++, you could do whatever you want, right? You could make addition and subtraction, right? And that's not a good world to live in. So consequently, most languages have some built-in operator overloading, but don't allow user-defined operator overloading. Java, you cannot redefine what plus means, what that symbol means, right? Those 3 things up there, those 3 situations are the only time that it makes sense, right? And it's fixed in the language and it ain't changing and you can't change it, right? Good.
For the vector, it would make more sense
Just create a method that takes 2 vector, that was probably an exercise in CS1, right? Vector addition. Just make a method that says add vectors or something.
C++ doesn't have classes, right?
Yes, it does. Yes.
Then shouldn't you create a vector class?
That's what you should do, yes. And then a method called add or something. That's how you should do it, yes.
Rather than using the list thing?
Question online? Oh, okay, it's just some rando saying hello. All right, sorry. Anyway. It is, I can't tell the difference between real people and bots unless you're, oh, hi, I'm doing fine. It's hello, how are you? I'm doing fine, right? It sounds like a bot already, but anyway. So parameterized polymorphism, okay? What I'm gonna do is I'm gonna change this into a count demo so that we can come back to it later. And let's go ahead and rename file there. There we go. And I'm going to take you back to C in Java, right? So new class, and let's go ahead and call it demo, and let's make a main method so I can play around with it, right? So I'm going to take you back first of all to the first few weeks of this course, and let's make a list of integers, and then let's sort it, right? So numbers is equal to arrays.asList of just some random numbers here, randomly sorted. There we go. Right. And yes, fine. Come on. Import list. There we go. All right. How do I sort this? I want to sort this. Of course, I could go collections.sort numbers because that is the natural ordering of it. That's going to sort it in ascending order. Let's print it out to make sure that that's how it's doing it. So len numbers. There we go. Awesome. Sorting in ascending order. I don't want ascending order. I want a reversed order. So I make a comparator for integers. Descending, I'll just say desc is equal to new comparator for integers There we go. Import this, semicolon, and implement the compare to method. Add unimplemented methods. I'm simply going to take O1 and compare it to O2, and then I'm going to return the negation of that. Right. Why? Because that's going to return something positive, 0, or negative, depending on the relative ordering of those things. And so if I reverse it and go negative, positive, 0, right, then it should work. I'm going to have to give it desc. There we go. Now let's go ahead and witness that again. Excellent. Okay. This is 2023 Java. In fact, this is since 2002 Java. So over 21 years of history here, right? This is how you've been doing it for 21 years. Let's jump back to pre-2002 Java, something that looks like C. Right? First of all, let's remind ourselves what it looks like in C. Right? What would it look like? I would have to call qsort, right? Oops. Yep. Qsort. There we go. And what would I have to pass into it? The array that you're going to sort.
Oh, sorry, that was
Yeah, that's binary search. So the array that you're going to sort, the size of the array, the number of bytes that each one takes, and then what's that last thing? The comparator. What does a comparator look like? Returns an integer, negative, positive, or 0, depending on the relative ordering. All right? It has some name. But what does it take? And we won't do the details here, but what does it take as arguments? Does it take 2 integers, A and B? Well, that's not a comparator though, is it? Right. Yep, const void stars A, const void star B. Right. Why? Because it was generic. We wanted qsort to apply to anything, including integers, doubles, strings, whatever. And so we had to erase the type of variables, and then inside the comparator, what did we have to do? Force A, B to become integer pointers. Right. Const int star x is equal to const int star A. Right. And const, I spelled everything correct, right? Yeah, const int star y of B. Right. Basically, I'm taking away any information that you have about this type so that you can give it to this generic function. And then within that comparator function, I am forcing it to become a specific type. What does that look like in Java when we live in the C world without types, without parameterization? We go back 21 years, and it looks something like this instead. What is this a list of? Right, you know that it's integers, and the name of the list is called numbers, but what if I just called it foo? Right? What's it a list of? I don't know. What is this a comparator for? Just looking at this? I don't know. Right? There's no type there. Let's take away the type of this. Let's take away the type right there. Right? And let's take, and finally, what I'm going to have to do here now is I'm going to have to make these into const void stars. But in the context of Java, it is objects. Right? Objects O, object O1, O2. Not all objects are comparable. So just like C, 50 years ago, what did I have to do? I have to force them to become the types that I expect. In this case, it was going to be what? Integer A is equal to integer of O1. Integer B is equal to integer O2. And now you can go return negative of A dot compare to B. Right. That works. Numbers descending. Why are you not? Oh, because I renamed it. There we go. It'll still work until it doesn't. It's still compiled. Why? Well, nope. This is a list of what again? I don't know. Some of them are integers, some of them are doubles. So when we go into this comparator and we try to force that double to become an integer, what's going to happen? not truncation anymore, it's what? You can't force a double to become an integer, right? Explicitly, even explicitly in Java, right? It's going to say that there's going to be loss of precision there and class cast exception, right? What would have happened in C, by the way, if we had used a comparator for integers and then gave it an array of doubles? Garbage results, right? Because like stuff has to be comparable to like stuff. Apples to apples, oranges to oranges. What do I have here? I've got an apple in my bin of oranges, right? So now you see the power of parameterized polymorphism, right? All this runtime error right here, right, that occurs, the compiler was not able to catch that because the compiler is not smart enough to see that this is a list of mixed types here, and therefore this is the wrong comparator because they're not all integers. But taking this back, undo, 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 right? Undo, 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 come on, all the way. Right. Now, I am living in a nice world of the last 21 years where we have strong, or static typing and parameterized polymorphism in Java. Right? That problem is no longer going to occur. Why? What happens when I try to put 7.5 into my bin of oranges? I've got an apple in there now. What happened? The compiler is able to catch that. Right? And so I'm not able to even run this because the compiler is refusing. No, this is a list of integers. You can only put in integers, period. Right? So, which world is a better world to live in? The world of C, in which you don't have this kind of polymorphic behavior, or the world of Java, in which case you do have parameterized polymorphism and this compile time safety guarantee? Which one? Probably Java. Okay, I would agree. Right now, C has its proponents and said you don't need this fancy schmancy stuff. No, we not need this fancy stuff. But you'd be surprised about how many people do not realize the power of this. For example, Pythoners. Python is the best programming language in the world. It's okay, but it doesn't have anything like this. Python, there's no static typing at all. Now, take languages that are not statically typed, Python, JavaScript, PHP, and you'll find that people are making efforts to add on additions to the language or new features to the language to force them to conform and become statically typed. I have never seen a statically typed language, people trying to make it dynamically typed, right? Except in a couple of instances. One of those bad instances that we'll end on here today is the following. Int x is equal to 42. Right? What type is x? An integer. String x is equal to 42. Can I do that? No. Hello. Now tell me what type x is. String. Var x. Tell me what type x is. Now it's not compiling for a couple of reasons here. Var.
Whatever, it's a variable.
Yeah, it's a variable, right? It depends on what you assign to it. Now, tell me what type x is. Int. Wow, did I save on any typing? No. Var y is equal to hello. Did I save any typing? 3 characters. Wow. But is it absolutely clear what the variables, what types of variables those are just by reading the code? No, you have to make an extra effort to look on the right-hand side to see that, oh, this is a string. Right? This is something that was introduced, don't quote me on it, but I think it was added to C#, and for whatever reason, they thought it was a smart idea to put this into Java, and it's not. I've never seen a legitimate use case for this stuff. Right? Don't use it. Right?
Python is that way exclusively as well, right?
Python, you just go x is equal to 42. Now it's, but then later on you can change it. X is now equal to hello. Right? Now it changes its type. You can't do that even with var in Java. Var x is equal to 42. X is equal to hello. That's not going to fly.
So it's now just frozen to whatever you have.
Yeah, it was going to be frozen anyway to an integer. Why are you doing that? Why are you have this var keyword?
Yeah.
Now, the var keyword in JavaScript has a completely different meaning. It's for scoping. you make it into a local variable instead of a global, or hoist it up to the some way. But no, Python is completely dynamically typed. You can change it and do whatever you want with it. And again, that kind of stuff, wild, wild west kind of stuff, anarchy stuff, right? That's not great when you have a discipline like computer science, computer engineering, software engineering. What I like to make the analogy is, anybody have colleagues or friends in civil engineering? Yes, no? Okay. So they design a bridge, they build a bridge, but they forget one bolt. It was perfectly designed, it was perfectly built except for one bolt. Is it going to collapse? Probably not, right? If anything, if the engineering relied on one bolt being missed, it was probably bad engineering. What about computer science? If you write a program, 1,000,000 lines of code, but you forget one semicolon somewhere, or one colon, or just one character somewhere, is it going to fall apart?
Almost definitely.
Almost definitely, right? This is not like other engineering disciplines. Computer science is not a science. Computer engineering is not engineering, right? It's something completely new and different, right? It's all those things and more, and it is way less forgiving. The less that you can make to chance and anarchy, the better, right? Because now your bridge is not going to collapse as much. As much, exactly. Yeah, go ahead.
Well, if you forget one wire in an electrical system, it would probably also not work.
Yeah, electrical systems are basically computers, though, right? So, I don't know, it might arc over if you're talking about larger systems, I don't know. Again, maybe the analogy is flawed, I don't know. I mean, biology, of course, you know, they get 0.5 milliliters instead of 0.1, 0.51 milliliters. I don't think that's going to make the big difference, right? I don't know.
Difference is a bolt is a part, a line of code is an instruction.
Right, but it's one single character among millions of lines of code, and it matters. Right? So it's a little bit different than other disciplines.
Also, did I leave a mouse in the lab?
I have no idea. You'd have to check. But the takeaway here is that the less that you can leave to chance, the better. You want stuff to be as predictable as possible, because if it's not predictable, it all falls apart. All right, so assignment 2 is due on Friday. Lab 5 will help you down there today if you want, and it is due on today at midnight.